Welcome back to BAS 121, Chapter 12. We're now going to talk about classification. So classification is where we actually use some of this information to predict oftentimes decision making. So the example we're going to use here is the credit approval decisions using data as to whether they're a homeowner, their credit score, years of credit history, revolving balances, to see if we can make a decision as to whether to approve that person for credit or disapprove that person for credit. I got to warn you right up front, this data set and the data set that's off the book online, I see slight differences, so you might not get the exact answer that's in our textbook. So I actually did a credit approval decisions updated data set that you may want to use. So the first thing we have to do in classification is we have to modify our data, right? Because we can only do work with numerical data. So we have to, as you remember, we have to code these as numeric. So homeowners is 0 if no, 1 if yes. Decision is 0 if reject, 1 if approve. So notice here we've changed the data. And now we could do some very simplistic classification. We could do some bubble charts. And I'll show you how to do those in Excel. The large bubble charts correspond to rejected, and the smaller bubble charts correspond to approved. Now you notice we could do some very simplistic here, which they've done here, is just have a rule that 640, a credit score over 640 we're going to approve, under 640 we're going to disapprove, and of our 50 data points we would classify, we would only have 4% that would be misclassified. In other words, this looks like one of the points that was misclassified because it's a big bubble on this side. So apparently there were some other things other than simply credit score probably impacting this, such as they might have had a very, very large balance. We could get fancy. We could get some points and draw a linear line. Well, the other one was a linear line, but we could put some slope into this equation, and rather than just say an equation, over 640 we approve, under 640 we could say we weight the credit score by a certain amount, add in the years of credit history. If that factor is less than 74.66, we reject. We'd have some misclassifications using that rule of thumb. So this is how we would figure out the misclassifications. This was a simple pivot table, which I can show you, where we take the data and we would say, all right, what did we predict in terms of approve, disapprove, and what did we actually classify, approve, disapprove? So where the predicted and the actual are different, like in this cases where the decision, we predicted 0 and we got a 1, that's why we misclassified 2. So we had 2 misclassifications, 0 here and 2 here. So about 4% probability of misclassification. So this is important because this sort of is an indicator of how good our classification rule is. Because we could say, if we're only misclassifying on a very rare attempt, that tells us our rule is probably pretty good. When you do classification, oftentimes you're doing this on very large data sets. So if you think about it, if I use the entire data set, there's sort of this self-fulfilling prophecy. Of course my model is going to be good because I'm using the same data in the model that I'm using to confirm the model. So it's sort of a self-fulfilling prophecy that I'm going to have a good model. So oftentimes with big data projects, the data will be partitioned. You'll take the data set and you'll put some of it into a training data set, You'll put some it into, and that'll be where you'll use that to develop and teach or train the data mining algorithms. There's what's called a validation data set that you use to fine-tune your model. And then there's a test data set that you'll use to test the accuracy of the model. Sometimes people only use two of these. They do the test, training, and validation. Sometimes they split it into all three. But the whole point is you want to have part of your data set where you develop your algorithms, and then either the test or validation data set where you test or validate whether that model was really good, really accurate. So what you're going to do is we're going to show you some partitioning techniques to how to take all the data and partition it into a data set, a validation set, and if you want, a final test set. So I'm going to stop here, and we're going to show you some of these techniques actually in Excel.